I will go through Lab 3 for Physics to Magnetic Field of a Bar Magnet. So an overview, for the goal of this experiment, we use 2 measuring sticks, 1 magnet, and 1 cell phone to determine the magnetic field of a bar magnet. And the results, I get n is equal to negative 9541 and the magnetic moment down there 3.0986, which I will explain further later in the next slides. So procedure. So to measure the magnetic field sensed by the phone sensor, first we need to eliminate the influence by the Earth's magnetic field. To do this, we use the app Firefox to find when the X component is 0 without magnet present. And then we place magnet on axis towards the phone's long side, which will be perpendicular. This way, we can measure the X component, which will show only the magnetic field due to the magnet. And then you determine the approximate location of sensor on phone using lab instructions. Then we measured the distance and the X component of the magnetic field at different magnitude. So we had 20 microtesla, 70, 120, and so on, all of them with 3 trials. Distance dependence of the magnetic field. So the magnetic field, its magnitude, can be modeled using this equation right here. And the magnetic field decrease as the distance increase. And the K we see here is a combination of constants including magnetic moment, mu, which does not change during this experiment. However, this is not really clear and helpful to our experiment, but if we take a natural log on each side, we can model the field, natural log of the field, as a linear expression of the distance and the constant K. And then, so this is the result. We've taken 3 trials of each magnitude, taken the average, and using the average, we found the natural log applied to them, and then we were able to plot this and have the y as natural log of the bx and the x field as natural log of the distance. As you can see, K here is negative 14.294, and which we'll use later to calculate the magnetic moment. So, magnetic field at 45 degrees. First, we found where the B net is equal to 100 microtesla and recorded all the values. And notice the Y component is only due to Earth now. Once we move it up a distance d perp, now Y component is a combination of Earth and magnet. So this is the final result for the 45 degree. So this is when we only moved a distance along the first stick, and this is only by Earth. And then this is the Bx component and the By component once we moved a d perp up the second stick. To find the corrected value for the magnet, we subtract Earth from the measured. And this is Z component and then B net. So coding, we will use this formula to model the magnetic field by the magnet at different locations. And as I mentioned before, K is a combination of constants including the magnetic moment, which is equal to this. And doing some math manipulation, we're able to find the moment to be 3.0986. So let's see coding. So first, the magnet is already created in the base code. All we gotta do is put in the moment, magnetic moment right here, and then we changed and created this function dipole B, which calculates the B field for different location due to the magnet. As you can see here, we applied a scale to make the arrows show better and the distance from where the arrows are showing, observation location, from the start. So this is observation location. As you can see, I use distance plus the axis of the bar magnet, and then it's different for each of those. So I have 2 on axis and 4 that's perpendicular. They are at different location, obviously. And then you use observation minus source to get the r vector, and then using the dipole B function to get its magnetic field, and then you plot it. So it's basically the same thing for this one. Those 2 are on axis, and then as you can see, those 4 are perpendicular, which is just the same procedure, and then same procedure again for the 45-degree, and then with the deep purple we measured. Okay, let's go back. So this is the code. This is the result we got. As you can see, this 45-degree, there is 4 arrows right here. 1 is blocked, that's perpendicular, and 2 on axis. Comparing the result, I would say the experiment and the code is very similar. This is X is off by a magnitude of 10. Y is very close, as you can see, and Z component I would expect that to be experimental arrow. So finally, discussion. If I hadn't oriented my experiment to compensate for the magnetic north, we probably won't have a Bx at any time to be 0, and the field by the magnet calculation will be off. And if I stick 2 identical magnets together, I will probably expect it to be like a super magnet, a large magnet that contributes to a higher magnetic field. So this is my presentation. Thank you for watching.